Hello and welcome. This is the fifth video of the series for the 55 physics problem for June 2019 NET exam. So the fifth problem goes something like this. We have a turntable is rotating with a constant angular velocity omega, and in the rotating frame fixed to the turntable, a particle moves radially outward at the constant speed v0. The acceleration of the particle is r theta coordinate as seen from an inertial frame, the origin of which is at the center of the turntable is. So what the problem says is we have a rotating turntable. So let's say this is our turntable, and let's say that this is our axis, okay? And the velocity of the turntable is omega naught. In the rotating frame fixed to the turntable, a particle moves radially outward at a constant speed v naught. So imagine that you have a particle somewhere here, and definitely from the center it will look like it is moving radially outward, so the particle will move in this fashion. From the center it will look like it is going radially. Okay. Now in the problem it is asked the acceleration of the particle in the earth theta coordinate as seen from an inertial frame, the origin of which is at the center of the turntable is. So from the problem you might have guessed that you have to find the effective force of the system, that is the Coriolis force and the centrifugal force. We need both to get the effective force. So we can write that F is equal to F centrifuge plus F Coriolis. Now the centrifugal force is minus m omega naught cross omega naught cross r. This is from the definition of centrifugal force. You can check out any book or from the web what is meant by centrifugal force. I will not describe this in this video. And the Coriolis force is given by minus 2m omega naught cross v, basically v naught, okay, because it is given that the outward constant velocity is v naught. So then what we can do is we can plug in the value of f. So f will become minus m omega naught square r cap, because it's on the radial direction, and the Coriolis force will be minus 2m omega naught v naught minus theta cap. Then we can write that acceleration is equal to f by m. So this will become minus r omega naught square r cap plus 2 v naught omega square theta cap, right? And out of this, which one is the correct option? So D is the correct answer to this problem. Hope you guys have understood what is going on. If you have some doubt, I would suggest that you go through some article where they have explained how to calculate the centrifugal and Coriolis force, and how do we get the theta, the sine of theta, the r cap, and the sines. So these things are described in any theory on any book on Coriolis and centrifugal force. That's all for this problem. If you like our video, do give a like, comment, and also subscribe to our channel. Turn on the notifications so that you don't miss another upload. And I thank you all for watching.